Ooh. So shall I start or shall we wait until 11?
Probably you should wait until 11, maybe 11:02, I would say even.
All right.
Yep. I'll keep an eye on attendance. So, whenever we have critical mass, I'll let you know. But if you want to keep looking at the attendant list, you're sure free to do so. Meanwhile, I was looking in the chat. I know some people were experiencing issues with getting their environment set up. So if anyone is going through this right now and they're in the chat, do speak up. Maybe we'll be able to help you a bit more easier than via text.
Yeah, it's like I can answer a question orally since like we will be 12 or so. I did practice with like 15 people, and answering question orally is usually doable with less than 20 on a stream. And also I did allocate time to set up the ESP32 environment like during the workshop.
All right.
So I'll wait one more minute and then I'll get started. All right. So welcome everyone. Marc-André Labonté. I'll be hosting the automated contact tracing workshop on ESP32. So let me share the screen. Share. Okay. So I was working as a system administrator at the McGill Genome Center. And then in 2016, I joined the ethic team at Desjardins as an infrastructure penetration tester. And these days, I'm doing research and testing on IoT devices. So I took a look at the Apple, Google, exposure notification protocol. It's like this spring. It was developed in 2020 to help the contact tracing effort to deal with the COVID-19 pandemic. And I did that research with a focus on privacy. It's like they had like the promises privacy to anyone who took part in that contact tracing effort. So I didn't want to look at it and look at the protocol itself and what's around it. Turns out that the protocol itself is pretty good for preserving privacy. It's like most issues that I found are related to it's like the device themselves, the smartphone will gather data for other purposes, and also telemetry that has been done. But the protocol itself, it's pretty good. We'll look at it. Since there are a few of us, you can ask questions orally anytime, and I'll answer them. Also, I will invite you to go at my GitHub repository. I'll paste it in the chat. Zoom, where is Zoom? Chat. It's like I stop sharing, paste, start sharing again. So you can pull the GitHub repository and follow using the workshop.md file. So first, we'll look at the protocol itself. So that'll be like theory, and then we will install the Wireshark plugin for the Bluetooth sniffer here. If you don't have the Bluetooth sniffer, there is also the Beacon Scope Android application that you can use to see the exposure notification Bluetooth advertisement. Or there might be other application that will allow you to see that. But for the workshop, we'll be using the Bluetooth sniffer. And then the main part will be setting up the ESP32 toolchain, the environment development. And also I discovered recently that this year NorthSec badge do use the exact same MCU. So you might use a badge as well. The only issue is if you use the badge, you lose the original firmware of the badge. So it's like if you want to play the game again, you'll probably have to use JTAG on the badge to restore the original firmware. All right. So a bit of lexicon first. The protocol has three main parts. The Bluetooth part, so that's the scanning and advertising happening on your usually mobile device, but we'll implement it on the MCU. And the second part is the communication with the public health authorities. So we'll look into it. There's two type of communication. The first type is when you have positive tests, you'll be sending your temporary exposure key to public health, and on Saturday you will be pulling from public health authority the exposure keys of those who tested positive to do the key matching. And the key matching is the last part, is the part that will determine if you have been in close contact with someone who has the disease, so you have to isolate and test. So first, the Bluetooth part. So we can see it with, yeah, that's the beacon scope. So there is a UUID for the type of advertisement, which is FD6F, and you will be transmitting like two main parts, the rolling proximity identifier that you transmit like every 250 milliseconds, and the metadata. The metadata is just for now the power at which you're transmit, and it's being used at key matching part to determine how close or how far you were when your rolling proximity identifier has been transmitted. So we can also see it with Wireshark. We'll configure Wireshark later. You need a plugin to use the Bluetooth sniffer. But if I start Wireshark and use that filter, I can see I have, this is not me. These are my neighbors who do run the COVID alert application, the original one. So I can receive their advertisement. So we can observe within the advertisement, there's a few things. First, it is like advertisement for a service that doesn't support connections. And also it uses a random MAC address. So the MAC address has to be random, and it has to be rolled over, it's like regenerated at every interval at the same time of the proximity identifier. We'll see it later. This is prevent tracking. And then again, the UUID for that identify the service is FD6F. And we see the rolling proximity identifier and the metadata. Metadata is, again, just transmit power. So when you receive that, you can also store the receive power and determine the distance between you and the person who transmit that. So any questions so far? It's like, I think you can unmute and ask question. Just try it. I'd like to see if it works, if I can hear somebody.
Testing.
Yeah, I can hear you. Excellent. Thanks. So that's roughly the Bluetooth part. And we can also, there's a small issue that I saw. Okay, all right. It's like when I start to research into that, I found a different version of the Google specification for Bluetooth. So this is an old document. It's not current. So it's like if you install the COVID alert app, should not behave like this anymore. We'll see the new document just right after. But it has an issue. It's like in the whole document, they plan a tracing key. So your device will generate a key once per device. And from that key, it will generate the exposure key that will be derived from that key. And then everything else, like the rolling proximity identifier, will be derived from tracing key. It's like they changed the terminology as well. It's like at that time they call that daily tracing key. So that caused the issue that it's by design that rolling proximity identifier has to be derived from the temporary exposure key. So the key matching can happen. But if that key had leaked for any reason, and then people could, if they had captured your rolling proximity identifier for a period of time, knowing your tracing key, they could track you. They could know where you've been during like month or a year. So that was like, I'll say pretty bad for a privacy standpoint. So this is not happening. It's like Google did a new document. It's like they updated the spec at some point closely after. So the new specification, this is the Bluetooth part, and we'll see from the cryptography part. So that's the current document. So this is what they do now. And what they do is like, now they generate the temporary exposure key from a random number generator. So this is what's happening. It's like once a day, the device will generate that key. And once every interval, it will generate from that temporary exposure key the rolling proximity identifier, which is being transmitted. And when you're scanning, you're around, this is what you get. You get these two. And it's like the next step is the communication with the public health authority. I'll zoom in a bit. So let's say you have symptom, you go get tested, you test positive, then the public health authority will give you a code which allow you to communicate with the API. So you'll punch that code and you'll send it to the API. The API will give you a token, and then we'll expect you to upload the last 14 temporary exposure keys that you generated in, whoops, not like the other tab. I want to get the other tab. Okay. I disable the waiting room, but yeah, please, someone manage the waiting room.
Yeah.
I just wanted that menu to go away. It's like when you test positive, these keys you generated once a day on your device. So if you you shall have a positive test, you will be uploading the last 14 ones. So it's like from the last 2 weeks. That is because like with that particular disease, you might be asymptomatic for several days, but still be contagious. So a 2 weeks buffer is like it has been deemed safe enough. So that means that before that, you might just delete these keys, so they won't be able to retrieve them. It's like they will be lost forever. So their rolling proximity identifier that you transmitted before will really be useless for tracking, thanks to the device tracing key not being there anymore. So you send them, what is that? Sorry, just I need that one. Okay. Whoa. You send them to the that's not what I want to see. I want to see you send them to the Public Health Authority, last 14 one, and that that will brings us to the last step. The last step is the key matching part. So to protect privacy, it has to happen on the user device. It's not happening on the Public Health Authority server. It has to happen on the device. And like we might have an issue with the ESP 32, we'll see why. To do key matching and determine if you are exposed, it's like as you use the system, you record rolling proximity identifier from other people who use the system around you, and you store them on your device. So these advertisements, you're supposed to record and store them. And then once a day, you have to fetch, it's like the application will fetch a zip file from the Public Health Authority, and that zip file, whose format is described there, contains the key of the people who had a positive test that day in your area. So then once you have that file, you have these keys. But the protocol is designed so from these keys, you can regenerate rolling proximity identifiers that were transmitted. So you fetch the file from Public Health, and you will, on your device, unzip and recalculate all the rolling proximity identifier from these keys from the zip file, and you compare them from those that you store from Bluetooth advertisement. And if you have a match, that means that someone who tested positive has been around you. And that's when the metadata comes in. It's like from the metadata, you'll have like a transmit power measurement. And as you receive on the Bluetooth scanning, you can also capture like receive power, and then determine the distance. So if you are in close contact, like less than 2 meters, then you'll be deemed exposed, and you'll get the notification that you are exposed, and you shall then test and isolate. So any questions so far? Okay, great. So let's move on. So yeah, the whole thing has been designed to be hosted on a modern cell phone. So a modern cell phone has like gigs of RAM and tens of gig of physical like non-volatile storage and pretty good multi-core CPUs. The MCUs, like they have more like limited physical resources, hardware resources, but can still be sufficient. And in the ESP32 case, I discovered that it's possible to attach an additional RAM chip on the SPI bus. And also the resources you need are correlated with the intensity of the spread of the disease in your area. So the protocol allow for each day you can fetch up to 15 zip file, and each zip file will contain, I think it's they could contain up to a million of temporary exposure key. So it's like you can have like one system for the old United States and it will still work. It's like it will support really intense spread. But if you have like more limited resources, and let's say you are in Quebec, it's like so far in a single day we had a bit over 3,000 cases. So that's mean that day that zip file, assuming 100% people taking part in the automated contact tracing, that zip file will have contained like 42,000 keys. And from these, you have to have like hardware resources to recalculate the RPI. And for a single key, you have up to 144 rolling proximity identifier. That's why you have to roll them every 10 minutes. And there's 144 period of 10 minutes during a day. And the next day you generate another key. So it's like take some memory, it's like some RAM to do this calculation for the key matching at the end. And Canada is like, I don't know if the system allow for contact tracing between provinces, or if they isolated the, let's say, the system in Quebec and Ontario has their own, and Alberta and everything. So I'm not sure how they are connected together. So if we fetch keys, we fetch key only for our province or for the whole country. But the whole country is like you'll have like 5 times more keys. And I think at the time I wrote this, that was our worst day, January the 3rd. But I think we had actually in April even more cases. It's like 12,000 or so. So that's for the theory. So now we are getting to setting up the sniffer. So any question about how the protocol will work? About the key matching or communication with public health? It's all clear. Yeah, I'll try to see the chat. Can I see it? All right, let's say it's clear. So let's go back to setting up the sniffer. So unfortunately, it's like if you use Ubuntu, Ubuntu by default, the Wireshark will be too old to properly parse the Bluetooth advertisement. So it won't appear at Google, Apple exposure notifications, like it will appear just as service data. So we need version 3.4, I think, of Wireshark. So if you have Ubuntu, you can get it through PPA. So you run these commands to install Wireshark. Just like try it. If you have Windows, then you can just pull Wireshark from the official website. Same if you have a Mac. It should work like the ESP32 tool chain can be installed, as far as I know, on Windows and on Mac and on Linux. It supports all three. Wireshark as well, and I think the NorthSec plugin also. So try it and let me know how it goes. So on Linux, for things to work properly, you need to add your user to this group. You need to be part of the dial-out group so you can communicate with the ESP32, that the chip or the badge, over the serial port. If you want to send and receive, you have to be part of the dial-out group. And Wireshark, you have to be part of the Wireshark group to do traffic capture. If you want to update your group membership without leaving the stream, it's like without logging off, you can use SU as your user to logging again, and then your new groups will be applied and you'll have permission to communicate with both the Bluetooth sniffer and the MCU. Also, to make the Bluetooth sniffer work, I install Screen to troubleshoot serial communication. It's not required, but the Python 3 serial is required by the plugin. It's a dependency of the Nordic Bluetooth sniffer plugin. So you can get it from the Nordic website. Just pick the version from the for the operating system you use. You see, will support Windows, Linux, and Mac. So you're fine in either cases. And once you download that plugin, you see from Wireshark, if you go to Help, About, and then Folder, you want to install it in the XTCAP folder. So it should be in your home. Where is it? Plugin, folder. Yeah. Okay. On Linux, should be in home, your user, .config, Wireshark, and XTCAP. So it's a personal XTCAP path. So this is where you want to download and unzip the Nordic plugin. So the install instructions are there. So that's what they tell you to do. Open Wireshark, look at the XTCAP folder, and you unzip the plugin there. And you can do that to test if it works. So let's do it. So if I go to .config, Wireshark, txt cap. So I have the zip file from Nordic. I just unzip it, and it should have unzip .sh file, a bat file for Windows, a Python script, and some more files in that folder. So I can test if it works using the Sniffer.sh. Let's try and run it. Need to right. So you get the path of the serial device associated with the sniffer if you have the sniffer connected to one of your USB port. And after you install the plugin, you stop Wireshark, you restart Wireshark, and then the sniffer device should appear. So let's do it. I stop Wireshark, start it. It's running already.
And I'll just jump in while you do this. So do you recommend version 3.1 for everyone, or is there any benefit to not going with the latest and greatest?
I'll say go with the latest and greatest. Go with this one, the 3.1, because it's like older version will support only Python 2, and they only recently upgraded their plugin to support Python 3. So I would recommend the latest and greatest. That's the one that I use. I know it works, so go with the 3.1.
Excellent.
So if everything is working, you should get that new capture device. So if you click on it, you'll see it's like Bluetooth advertisement of like any kinds. And here I'm in a building and we are like 50, it's like 50 co-owner of the building. So that's a lot of people, and my neighbors do buy every IoT device they can find. So that makes up a lot of advertisement. So we need to filter them. So here's the filter. It's in the workshop.md file filter that you should use. So that will filter so you see only the Apple, Google kind of Bluetooth advertisement and not everything else. So I have it here. If I do apply the filter, I still see a lot of traffic. Maybe if you live in the countryside, you have your own home, no neighbors, you won't see anything. When you'll run the code on the ESP32, hopefully you'll see your own transmissions. Or what you may also do, if you don't see anything, if you want to generate traffic, you might pull the official app. So that's the link. So worst case, you can go on, install the official app. It's like, and you uninstall after if you need to generate traffic. But here it's not an issue. I have plenty of people around me who runs it, so I can see their advertisement with their rolling proximity identifier. And
So we have a question in the chat about the type of range you can reach with BLE.
I think it's at least 50 meters. I don't know for sure, and I don't know the impact of like dry walls, wooden walls. concrete walls and like open space, but it's at least 40, 50 meters. It's like, I think I see what I'm seeing is not the neighbors like above and below, because like the ceilings, the floors are reinforced concrete, so like that's metal and a thick layer of concrete, and like also 1/4-inch layer of steel. It's like a steel plate. So I don't think I'm seeing like the upper neighbor or lower neighbor, but I have like huge glass windows, and my neighbors across the street, I think that's what I'm seeing, and they are at least like 20 meters, 30 meters away. So I'll expect up to 40 meters maybe. So that's the range. So that's why it's like, if my neighbor across the street do test positive, it's like I will still record his RPI, but I'm not really exposed. So that's why the protocol allow in the metadata a record of the power, the output power when you're transmitting, so it can calculate the distance a bit better to reduce the amount of false positive. It's like when you have exposure notification, the application wants to make sure that you are really close to someone. So they had it like in the first document that I showed you, they didn't plan it, but they had it shortly after in April 2020 in version 1.2. Any other questions? Right. So that's pretty much it. Like at this point, the sniffer should work. So we'll install the toolchain itself. This step can take, like, I would say on my machine, I have pretty good machines. Like I have like a fast hard drive and a fast internet connection. It takes like 3 minutes. So it can take like 5-10 minutes if you have like a slower drive or like less internet bandwidth. So you may just follow the instruction on the ExpressIF website. So first you clone the repository. I'll do it, so I'll see how fast it goes. I'll do it again. CTF NorthSec, make folder test2, to test2, and let's clone it again. So it takes a bit. I hope it won't. If it does disturb the Zoom, just tell me and I'll stop it. So once it's done, you go inside that the ESP EDF folder, and you run the install script. It will pull some more code and pull Python modules, and then it will be ready to run. So that's what it might look like on Windows. And then the last step is to run the export.sh. Where is the export.sh? Yeah, it's there. So the export.sh script will load your environment, it will create a Python virtual environment as well. And then you'll have access to the edf.py script that you run to build and flash and monitor the device. So it's 11:43. I think either we can like have a question and answer, a discussion, or we can take a break until like 11:50. So it's like everyone can pull and install. It's like it seems to be done on my side. So if I run the install script, yeah, so it's because it does store code in a dot folder, I think, yeah, .expressif. So it was pretty fast on my machine because I did it yesterday. But yesterday when I tried my own workshop, it took like 5 minutes. So if you wish, we can have a discussion or take a break until 11:50. So everyone will have like ESP32 install and will be ready to go and try the last step, which will be building and running the actual code. We will do a walkthrough of that code as well. So we'll look at the source file. There is a Mark file. That's the README. I need to go back to workshop. It's like the code is split in 4 files. So we'll go through them at 11:50, and we'll see like what are the important functions, the data structure that you might want to look at to really understand how it works on the ESP32. So any question or comments so far?
I'm also keeping an eye on Discord, but do ask your questions here. And if you want to ask them with a mic, it's even easier. If not, it's a good time also if you've got everything just getting set up, grab some hydration. It's very tropical weather in Montreal right now, or wherever you may be. It's always a good idea to stay hydrated.
Yeah. So let's take a break and go back at 11:50. Should be done. Should be take like 5 minutes. So I will stop video and mute and unmute at 11:50. Is that correct for everyone? Excellent. So see you at 11:50. All right. Yeah, I got a question. It's like if you have the error message, no module name serial, that module is actually a Python 3 serial, so the Python code can communicate with the sniffer device using a serial port, which should be like something like TTY USB 0. So you have to install that package. So if I go back, oh, that's strange. So yeah, one can install using PIP, but what I did is I installed it using the package. If it's like it did work on Ubuntu, if it still doesn't work, let's say you use the package manager to install, because there is Python serial and Python 3 serial. So make sure you have the 3.1 version of the Nordic plugin, and try it's like on my Ubuntu machine, the package is named Python 3 serial. It might also be named on different operating system Python serial if the operating system like maintainers do assume that Python means Python 3. Otherwise, I'm not sure, but maybe you can try to pull Python serial yourself and put it in config Wireshark scat. See how this work. Just simply do require that it tries to import serial. So just make sure if you run Python 3 here that you can do the same thing and import serial without getting an error message. So that's how you test it. If it installed properly, then import serial should work. Yeah, also on Windows, I don't have like I didn't test it on Windows. It should work as well. I just don't know exactly how you get additional Python module installed on Windows. Import serial work. Yeah. You might try a virtual machine. If you do it on a virtual machine, then it's possible using whatever hypervisor software to assign USB devices to the virtual machine. So it will disappear from the host and appear under the virtual machine. So if you want to see if it's there, so I'll zoom it and I do ls USB. I should see that's the sniffer. And if I do connect a badge, I should see the badge as well. So if you decide to run the whole thing on a virtual machine, yeah, that's the badge. And if I do connect this thing, the dev board that I bought for the workshop, yeah, I think this is a Silicon Labs CP 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 210. So that's that controller. All right, excellent. So at this point, it's like you should have the ESP32 environment development installed. So to test it, I didn't install the ESP IDF. You need to load export .sh, and from there you should have like idf.py in your path. So once it's done, go into CTF. Like if we want to build a thing, we do go into the MCU trace folder that you should have pulled from GitHub and build it. So when you do it from the first time, it will take like 30 seconds, 1 minute to build, but it's like I've did it before, so it's just done. It will show the message so that if I want to flash the device, then I should run idf.py with the port. Since I got the sniffer connected as TTY USB 0, then I connect as ESP32, should show up as TTY USB 1. If you use Windows, that will be port COM1, COM2, COM3, and so on. So before we do build and flash the device, let's do the walkthrough of the code. So it's not done yet. It's not following the specification. It's like I did the experiment. I did it as an experiment. If the pandemic drags on because of variants, or I will finish it. It's like, and I'd like to finish it to have it if there's another pandemic shortly in the future. But for now, I did the Bluetooth part, so I'll go through it. But communication with public health is still missing, although I could reuse a lot of code from Google, because I think they use the Apache or MIT license, so it's cloud. And the same thing, they did the key matching part in C++, because it was faster than doing it in Java. So when I did before, Google do the key matching here. It's like the C code is called from Java by the applications using GNI. So I could probably borrow that code, Apache license, to do key matching on the device. But so far I did only Bluetooth. And it's not up to spec for two reasons. Like, I'm missing the real-time clock. So it's like for some part of the crypto code, I will need to set a clock, and to set the clock on the ESP32, you pretty much have to have Wi-Fi on and connect to access point, and either use NTP, or you can even use TLS to get the time. So that part still needs to be done. And also, instead of storing the temporary exposure key for up to 14 days. So like right now, the code will generate one every interval period. So every time the code like regenerate the rolling proximity identifier, and the Bluetooth MAC address will also generate the exposure key, but it should not do that in real life. In real life, they should be generated once a day and stored for 14 days. So let's go to the first file. So you go in the main folder. So the first file to look at will be ESP exposure API.c. So this is borrowed from the iBeacon example on the ExpressIF repository. So I took iBeacon and I turned it into exposure notification. So these are the two critical data structure. So the service header, what it really do is it will set this as the service data, but this part of the header. So we'll have the length of the header itself, and also the service UID, which is exposure notification UID, which is again FD6F. So you set it and you pretty much forget it. This is static. This won't change. The next part, though, the payload, that will change every 10 minutes. For workshop purposes, I set the interval at 10 seconds. Every 10 seconds, we regenerate the rolling proximity identifier, the metadata, the temporary exposure key, so we can look at it without waiting for 10 minutes. But that's the, they call that the exposure notification interval. So about that, we'll have the, no, not this one. Oops. I want to have, yeah, this Andy. So this is the crypto codes. I want to have the schematic Andy to help you understand how it works. So this has to be changed every time the notification interval does elapse, which is usually 10 minutes. So this function here, roll proximity identifier, will receive both the RPI and the metadata from the crypto part of the code and update the structure here. And this function is called by a scanning event. So you run the scanner as well. And every time the scanning event receives something, will trigger an event and send you the payload from the scanner. Then this function will parse it to determine if really is exposure notification. It's not complete. It doesn't really check everything, but they will show, just print out the rolling proximity identifier that was received. But really, what should be done is these should be stored on the device to do the key matching protocol. If when you receive temporary exposure key from public health authority of those who test positive, then you run a key matching algorithm. And after a while, it's like you just drop them. It's like after 14 days, because like after 14 days, they're really useless. So this function should parse the advertisement received from the scanner, and then once determined they are properly it's like valid exposure notification advertisement, store them for key matching. But so far it's not done, just prints them. The last part will configure the advertiser. So it's called from the main file, and when the advertiser is turned on, we'll update the data structure that are used by the Bluetooth code with this. Like you update this one with your new identifier, then turn on advertising again. So, so far so good. Any question about this part of the code? All right. So the next file that is just look into the header file. Yeah, the header file just define the structure. So the next file that is interesting is the timer. Again, this is borrowed code from the timer example. So what's really interesting about the timer, two things. First, the interval. So it triggers every 10 seconds, but should trigger every 600 seconds or 10 minutes. And once it will trigger, it will call that function from the main file. So the rolling proximity identifier can be regenerated, and the MAC address for the advertisement should also be regenerated. So every time the timer triggers, that function get called. So that's pretty much it for the timer. And the last part, let's say the crypto code. Yeah, this makes use of the embed TLS library, which is part of the ESP32 tool chain. So when you pull the code from ExpressIF, you'll get this TLS library. I had to turn on the hash key derivation function. It's not like enabled by default, but when you pull the GitHub repository, there is a file called SDK config. In that config file, the H key derivation function has been enabled. But it's like if you start from scratch and try to use this, you'll get a linker error. And if you look it up, it will tell you that you should enable this. If you want to enable additional function from the ESP32 tool chain, you can use edf.py, and I think it's menu config. Yeah, so this is if you you want to enable some other part of the tool chain that has to offer. So I'll have to do it at some point. If I want to do everything, including the key matching, I'll have to use Wi-Fi. So enable Wi-Fi, probably enable the NTP protocol as well to keep track of the time. Whoops. Let's go back to main and then crypto. So this H key derivation function is used there and there. So you generate your temporary exposure key, and you also the spec have you keep track of the timestamp at which the key is being generated. What is really interesting is the use 32-bit value for the timestamp. So it will have a problem within 2 decades, like will roll over. So if that contact tracing protocol keeps being used, at some point they will have to update to a 64-bit timestamp, I think. And the interval, which is like 144 period of 10 minutes, you have to keep track of that as well, and the code still not do it. I'll do it in the future, and get the temporary exposure key from a random number generator. So when you call this, you have to also call it with the static string, which exposure notification RPI key. So since a static string is being used, that means that someone who knows the key can regenerate all the rolling proximity identifier from that key. And that is critical for the key matching. So when you upload your key to public health authority, it's like the only time that you disclose this key is if you test positive and you decide to contribute to the contact tracing, so that the official application will still have to ask for your permission to upload the keys. Otherwise, they always should stay in the device. So when you upload them, they will get distributed to everybody who use the contact tracing. And from these key, they will run the key derivation function with the static value, and they will be able to recalculate the RPI. So we do it once. We do the key derivation function. Then from that, you get the RPI key. And from the RPI key, we have to generate like a plain text using, again, this is known, it's like it's from the interval number, so 1 to 144, and it's like padding data, which is like a bunch of zeros, and again a static string. So this plain text, it's really it's known as well. So from that AES output, you get really the rolling proximity identifier, which goes over Bluetooth. So in the code, I'm using AES in ECB mode. It's like if you look into AES and like symmetric cryptography and mode of operation, it's like you won't like this mode, because it will create like huge issues if you use more than you use that for more than one block. But here, since it's like we only have one block to encrypt, and the embed TLS doesn't expose AES directly, So I have to use ECB mode to do this, but it's okay since I use it only for a single 16-byte block, and it's really to get the RPI from that key. And the thing that is critical here is like someone who run like a Bluetooth capture device that's in shopping center cannot track someone by recording to the Bluetooth traffic. So as long as these stay secret, so as long as you don't test positive, then it's like no one can do the calculation reverse. So the only way you can be known if you have to publish these, then your RPI for the last 14 days will be known as well. But otherwise, it is safe. The last part of the crypto code is to protect the metadata. So that's the output power measurement. So again, you do key derivation function with another static string, which is in the spec here. And that gives you the associated encrypted metadata key. And from the proximity identifier, you use it as a nonce input in the AES and counter mode. And the reason here why the counter mode is being used is the size of that associated encrypted metadata part is only 4 bytes. And in EES, usually the block size is 16 bytes. But what the AES in counter mode does is turn AES into a stream cipher, which can encrypt an arbitrary length of plain text. So it doesn't have to fit the block size, and it doesn't have to use padding to fit the block size. So you can take a 4-byte plain text as input and have a 4-byte ciphertext as output. But to get that, you have to use the counter mode. So the last part, like the specification will specify the format. Like I think I have to go back to Bluetooth specification to see how the metadata is produced. So the current document. So if I look for metadata, it's like carry protocol versioning and transmit power for better distance approximation. Like, and they will tell you, yeah, okay. So this is what needs to be done, but so that the code doesn't do it now, so only the future. But right now I'm using a static value as the metadata plain text, but to follow the spec, I'll have to get the transmit power level, and it's possible to do it with the ESP32, and then fill the rest of the structure as instruct here in the Google specification. So let's get back here, the last part of the walkthrough, which is the heart of the program, who brings all of that together, the exposure notification.c file. So any questions so far about the timer code, the advertisement part, or the cryptography part? All right, let's do it the last part. Here, in that file, we have another, like, shouldn't really go into that file, but we have another data structure to set the advertisement interval and also the scanning parameters. So I took these value again from the Google specification. So you should transmit between every 200 to 270 milliseconds. So I think you have to target between that and use some entropy to try to avoid like timing attacks. Like someone could run a Bluetooth listening device and use the amount of time between each of your advertisements shall then be unique to track you and differentiate you from other user, even though your rolling proximity identifier does change and your MAC address does change. You have to be aware that you can be tracked in some other ways, so you have to introduce randomness in timing as well. The entry point, next part is the entry point in a ESP32 is called app main. So when you'll build with the build command will create the firmware from your code, and mostly the ESP32 code build a firmware image, and the firmware at some point will call app main, which is the entry point of your code. Then from there, you have to initialize storage. Then at some point I'll have to use storage to store my keys that I generate and the identifier that I do receive. And you have to turn on Bluetooth. One thing that I got from the ESP Express IF documentation is if you have to use the crypto code or even the random number generator, for the random number generator to work properly and generated like cryptographically safe random numbers, you have to enable the Bluetooth stack and or the Wi-Fi stack. So when you enable Bluetooth or Wi-Fi or both, then the system will get entropy from these sources to be able to properly generate random numbers. So if you don't have Bluetooth and you don't have Wi-Fi, then you won't have a good random number generation. So first thing, turn on Bluetooth. And then I do generate a random MAC address here to start, but that should go in the, like if you remember, the timer will call this every time notification interval elapse. So it should be called every 10 minutes, but I should call it once at start to get my RPIs and my encrypted metadata and my MAC address generated. So small thing to fix. And then the next step is to restart the scanner. So I do start Bluetooth scanning first because I wanted to the random number generated to have like good enough entropy. So before I do advertise anything, I start the scanner. And the scanner will eventually generate events, and this function does handle all the Bluetooth related events, so by the advertiser and the scanner. So you start the scanner, then eventually you'll have the scan start complete event, and then from there you can start the advertiser. So it should be fine to use the random number generator to generate your MAC address and use the crypto to generate your rolling proximity identifier once you know that the scanner is up and running. And there is another interesting event is this one, scan result. So when the scanner receives a notification, then it will trigger parse the parser to make sure it's really exposure notification related. And then so far only prints it, but to do the key matching, you have to store it. So you receive. This is called when the advertisement is being received by your scanner. Then you parse and you store. And the last interesting part before we go into building and running and see if it all goes well is the timer RPI interval. So that's where the key generation and crypto happen. So you see here, metadata I use 1, 2, 3, 4, but here it's to follow the specification. I should get like power measurement, and there is also versioning. So I need to create a data structure here and store power measurement. Also, it's the exposure notification interval. This roll over each days when the temporary exposure key is generated. So only for the workshop, I don't use it, and I do regenerate the key every time this function is called. But the specification every 10 minutes that this will trigger, and you increment that counter from 0 to 144, and at the end of the day you roll back to 0 and you generate another key. So first thing, I will stop the advertiser because I have to replace the MAC address and the data structure that is being advertised. So I generate a new MAC address. Interesting thing, if you want to follow the Bluetooth advertisement specification, for random MAC address, you have to set the first 2 mostly significant bit to 0. So that tells the other scanner around that you are using a random MAC address. So it's some sort of convention. And then I do a print the generated address. Then I generate the temporary exposure key. Again, should not be done every 10 minutes, but once a day. And also another part that is missing is I need the real time clock. It's like it has a real time clock in the ESP32, so I need to use it to get the timestamp. So it's being used to feed the ES part here. So far only it's like E interval should be a 16-bit structure with the timestamp, the interval number, and the padding. But so far I only set it to 1. So I get the HKey derivation function to generate the RPI key. Then I call AES with the EN interval structure, which we saw earlier, and the RPI key to generate the rolling proximity identifier, which will go over Bluetooth. And then I call the Q derivation function again to generate the AEM key. And this is to protect the metadata, which is version and power measurement. And I'm getting a cipher text of 4 bytes out of it since I'm using counter mode. This is again according to specification. So here I do update my Bluetooth advertising structure, and I restart the advertiser. So that's it for the walkthrough. So we're getting ready to test the whole thing. So any questions so far? All right, we'll finish a bit early. So to test it, what we want to do is run Wireshark. Oh, the embed TLS HKDF is supplied with the Express IF toolchain. So when you go and install it, you'll get the embed TLS library as part of the code that you'll be pulling. When you do the GitHub clone recursive, you'll get it. And it's like I said, I had to turn it on. So if you want to turn it on, you call edf.py menu config. Takes a bit. All right, and should be in no security feature. No, probably try to remember where is it. Component. Oh yeah, ESP TLS, embed TLS. Yeah. HKey derivation function. Yeah, it's there. So this is not ticked by default. So let's say you want to run, it's like compile this code, but if you don't use my SDK config and you don't tick this, the code will compile, but you'll get a linker error. So that's where you get it. Then if we call edf.py build, should build it. Right. So if it does build successfully, you'll get that message, run edf.py -p, and then the serial port of the ESP32 chip you're using could be either badge or dev board. And use the flash command. So on my machine, port should be the TTY USB1. I'll use a flash command. So see a nice flashing progress. All right. So when flashing is done, you can use the monitor command to access the output when the code running on the MCU prints something. You can access it over the serial port using the monitor command. You can either combine the flash and monitor command, so you can do flash monitor. So flash, then connect to the running code so you can see the output. Or if you don't want to flash it, you can use the monitor command alone. So it will connect to the serial port and it will do a reset. So if your code is already running, I think monitor does a reset. It might be a way to connect without doing a reset. I just did not look it up. So if we do monitor, then I can see again the rolling proxy proximity identifier of my neighbors. And here, every 10 seconds, the timer ticks, and we'll see the output of the crypto code and all the keys that I do generate, starting with temporary exposure key, the RPI key, then the RPI itself, AEM key, and then the encrypted metadata. And as plain text metadata, I use 1, 2, 3, 4, which is not up to spec, but it will still show you that the encryption is working. And to test everything, now we have to use Wireshark, or you could use a beacon scope if you don't have the sniffer. So you select the NRF sniffer capture device, start, then without saving, then we run monitor again. So we let it go and we let the timer tick a few times, and we'll see if it is working properly. So timer did tick. Let's wait 10 more seconds. All right. So if you want to interrupt, the key to interrupt, it's control and then closing square bracket. So this, oops. Oh, I want to copy, then paste in the chat. Yeah, this is the key combo if you want to interrupt the IDF monitor process and get out of it. Okay, I'll redo it again because like I have lots of neighbor who generate a lot of notification. So I'll restart the Wireshark capture. Again, start Wireshark, monitor. And I'll let the timer tick twice. So that's once. It should tick again in 10 seconds. Right. Let's stop the capture and see if it did work. So I should have seen several notification with random MAC address 23, starting with 23.9b. So 23.9b, I saw one. So let's look at it. So we have 23.9b, and RPI should start with 6F C695. So we have rolling proxy identifier. Indeed, it does start with 6F C695, and the associated encrypted metadata I set should be 6D, AD, 94, AC. We see it, so it works. And if we go one tick before, I add that MAC address. So 1A E9. So 1A E9, you can see it here. RPI should be 27.7F. Yep. And encrypted metadata F9, F4, B59. So yeah, it works. And we also can receive additional transmission from like people using the application around. So I should see 2F E4. Yeah, the one that I saw, 05 ED. Yep, also captured by the sniffer. So Bluetooth advertising works, Bluetooth scanning works. So the thing left to do is to like fill the structure as per specifications, like for encrypted metadata and also interval notification. Like generate the temporary exposure key each day, keep track of the interval, store the keys for 14 days, store received proximity identifier for 14 days. That will complete the Bluetooth part, and then implement dialogue with the health authority and that last key matching. It's like key matching itself is like another good workshop. So any questions, comment? It's like we have like plenty of time.
If you have any questions that are on ESP32 generally, also within this topic generally, doesn't need to be super precise. You have the benefit of Marc-André's time, so go for it.
Yeah, just looking for yeah, it's like there's a few last thing as well. It's like anytime you can interrupt me if you want to say something. It's like when I look at the protocol itself, each of the three parts, it's like since I personally I'm not so comfortable with carrying like Apple or Google smartphone around. What I do carry around is it's like a phone with Android ROM that I compile myself, and I checked it. It doesn't have it. It won't initiate egress flow to Google. I mean, at all. I don't use Google Play. It's like I will use either F-Droid or ADB to install app. But for the Apple Google notification protocol, it's pretty good to preserve privacy. The problems are around it. One problem that I did found especially is they call that telemetry. And I'm not comfortable with that for like several reasons. We can see it's like this is what Google collect, and they say they won't like log IP addresses, but egress flow will still go to the infrastructure. And I think to really trust that, I will need like one external party that will audit them, sort of like PCI DSS, but for privacy. And I don't even think GDPR does that. I'm not sure, but I don't think it will send auditor to see if they're the manufacturer or the company that does gather data really do what they say they do with the data. So that's why I'm not comfortable with telemetry so far. So that's why I did try to redo to try and participate in contact tracing, but still without allowing that data to goes out. So I retain control of the other flow that are transmitted. And that's Google telemetry. And also the official developer for the COVID alert app in Canada. And it's like last spring, or I think it's last summer, when they got the COVID alert app out, it didn't really follow the spec and didn't send anything. But in February, they start to collect and send additional information. And again, they say they don't link your IP address with what you're sending, what the application is sending. But still, it's their infrastructure, so you have to take their word. And the monitors are pretty interesting things. Like if your state changed to expose, they want to know it, so they will know if you really like do the thing and trace and isolate, get tested after you get the exposure notification. So yeah, I'd like to have a way to opting out of that, but the official application doesn't allow that with the graphical interface. Like if you really want to opt out, you have to compile it yourself and it's like comment out the code that generate and send this. And also it's like cell phone, it's like they have many other sensors, microphone, and they can be turned on and used by any unrelated app. And it's like that's why I wanted to have contact tracing on another device. And also another thing is if I lost the link. If there is a Bluetooth exploit, if you run the app on your phone and there is a Bluetooth exploit, then you have your Bluetooth stack exposed. And it's like if someone can get there, usually the attacker will have like privileged access on the device, and that's really not the keys or the data of the contact tracing app that is exposed, but the entire device. But if you use like a separate dongle and you don't use Bluetooth on your phone, if there is an attack on Bluetooth itself, only the keys that you have generated in the last 14 days, and perhaps the rolling proximity identifier that you capture as you walk around will be exposed, but not your personal data that you might have on the mobile device. And so again, as that device key issue that was in the specification at first, but yeah, Google fixed it and they remove the tracing key entirely in the current specification. So that is pretty much it for the workshop. So any one of you can confirm if you got it working. So now I can help if you still have like a Python serial issue, or issue with the Wireshark with the plugin, or issue with the ESP32 part. Now I can help. We have like plenty of time. So anyone got it to work? You can turn on your
everything is working. Thank you a lot. I learned a lot in the last 24 hours.
So did you try to install it and run it before the workshop, or you did it this morning?
Oh, for the Bluetooth device, I do my setup yesterday, but for the ESP, I start this morning, and it was a little bit longer than expected.
Yeah, it takes a bit. It's like that's why I took a break at like right before 11:50. It's like I did tests. I have pretty good machine with NVMe storage, so it's fast, and it takes like 5 minutes to pull and compile the ESP32 code.
It was cool. It was cool.
So you get Wireshark working as well with the sniffer?
Yeah, but I do I cheat a little bit. I do the working on Windows.
It should work as well. It's like everything should work on Windows. I'm just not sure how to install Python modules. Like I did it. It's like I did install Python and install.
I do the follow. I do all the step that Adafruit tell us on their site, and it's working fine. Because I plan to teach this stuff, Bluetooth stuff, to my student in the next session.
Oh, nice!
It's why I try it on Windows, but for the ESP, normally I use Arduino to play with the ESP32.
Yeah, I noticed it. I never used Arduino. Like I just do as I showed you, and yeah, you can have fun if you want with my code. If you want to demonstrate, that's
well, I play a lot with the badge in the last 2 weeks. I saw the tool change with and I'll try it. I'll try, and it's working. First the Blinky, and now your code. It's good.
Yeah, it's working. The only issue is like I could not back up the original firmware, so I need to find someone who has it and then restore. Either I think it should work. I should be able to restore it from the serial port since it's
Yeah, it's
definitely yeah.
On Discord they say that they give the entire stuff next week. The source code and the binary, I think.
Yeah, so
You can refresh it.
yeah, so I'll do it then. I didn't have the time. It's like I played the game for a few minutes, but I really had to try to see if my code would work on the badge, so Florentia can announce it. So
Yeah.
yeah, I lost the NorthSec. It's like the LED won't even turn on except that one at the high. And since I don't use the screen, then now the screen stays off.
Yeah.
Yeah, so I have to fix it. It's like on Wireshark, do you see like any people in your area that are using the app?
Yeah, I saw a lot of stuff. I don't know who is this guy because I don't have the application on my phone. My Bluetooth is closed, but I see.
That's why I did this, is to keep Bluetooth closed on the phone itself.
Yeah. Maybe if I put the two device in old PC casing to do a Faraday cage.
But you can use like it's like if you have an old phone laying around, you can use that to play with it. You get the app running on it, then you can check it with Wireshark. I have like at least I think 4 neighbors. When I turn on, it's like I will turn off my own device. So and I turn. So I have like, this is 1, 2, 3, like at least 3 people in my area that are using the app.
Yeah.
Yeah, so thanks for attending. And it's like at 6:30, I think I was invited to take part on another hardware panel, so I'll be there.
Okay.
And,
thanks.
Yeah, you're welcome.
Bye-bye.
Bye-bye. So anyone else?
I was going to say, if any of you have some questions, but you're kind of holding on to them, it's also perfectly fine to hold on to them and ask them at the hardware panel later today. You can ask them on Slido, and I'll be happy to sling them to our panelists there, which Marc-André is going to be one of our special guests. No questions on my part. I think this was extremely clear, a great walkthrough. I loved the pace. I think this is this was a treat. So thank you.
You're welcome. So see you at the hardware panel in a few hours. And otherwise, have a great NorthSec and have fun at the CTF competition.